Hi friends, welcome back to Mentrix Max channel. Today we are going to discuss the chapter Inverse of Trigonometric Functions. This is an important chapter in class 12. In our previous chapter, that is relation and functions of our class plus 2, we have studied what is a function, what is inverse functions and so on. So now here we are going to discuss what is inverse trigonometric functions. Before going on to main topic, first of all we have to know what is a function, what is an inverse function, what are the types of functions and how we are applying these inverse functions to trigonometric functions. So here let's move on to the what is an inverse functions. We have studied a lot about this. In a simple language, I will give you what is an inverse functions. I will explain that. Just an example. Look here. 6 into 4 is equal to 24. Then when we reverse these functions, what is the reverse functions of multiplication? That is 24 divided by 4. That is equal to 6. Here what is this? The three numbers we applied it for this operation is same. But what here? Here multiplication, and when we reverse this number, that is 24 divided by 4, we got the answer 6. So what is inverse means? Reverse of a function. So here what is? Here inverse of multiplication is division. So reverse order of these numbers. So here we are explaining, in this video we are explaining what is an inverse function. Now let's discuss what is a inverse function. If you have a function that is moving from set A to set B, then what is that? It is defined as uniquely, the function is defined as f of x equal to y. Then suppose there exists another function, that is a function g, that's moving from set B to set A. That means what? Here the sets are switched to another. That is here reverse order. Here the set A to B. Here functions is moved from set A to B, and here the functions is moved from set B to A. Then it is defined as what? G of y is equal to x. Then we can say that the function g is an inverse of the function, that is f inverse x. For example, here we got an answer f of 2 equal to 1. Then what will be the inverse of these functions? That is g of 1 is equal to 2. So what we can say? We can explain that g is the inverse of f inverse. That is g is the inverse of f. Or in other words, we can say that g inverse 1 is equal to 2. That is f inverse 1 is equal to 2. When we get that, that is that f inverse 1 is equal to 2. So this is the inverse of the functions. Now let's move on to what are the types of functions that we need to understand for the further clarifications of the inverse trigonometric functions. Before going on to inverse trigonometric functions, we have to know what is the types of function. That is, there are 4 types of function. That is 1-1 function, or in another words, it is said to be as injective function, many-to-one function, onto function and into functions. These are the 4 types of functions. Let me explain what is 1-1 functions, 1-2 functions and many-to-one, one into functions. So what is a 1-2 functions? For that, first there exists a function that from A to B. What is that? Here let me give us set A and set B. These are the elements, that is 1, 2, 3 are the elements in set A, and A, B, C are the elements in set B. Then what is 1-1 functions? Here 1-1 function is if any elements, if all the elements in the set A have the image in the set B. For example, here 1 has an image in set B, functions exist. here, this type of functions we define as 1-1 functions. That is, all the elements is in set A as the images in the set B. Then if every element in set A has image in the set B, then we can define this function, that is functions f from A to B as 1-1 function. Now, what is the many to one functions? Before that one, I will give an example in hint that in our classroom, what is our atmosphere? Here there is a teacher for many students. One teacher for many students. One teacher is explaining to all students. So this is an example of one to many functions. Here, what is this? Here this one, that is the elements of the set A has more than one elements, that is more than one images in set B. If it is like this means, then we can define this function as one to many functions, because what one element has many images in the set B. So such function is called as many functions, that is one to many function, that is one to many. So best example is our classroom atmosphere. That is functions exist that's move from A to B. What is that? One to many function. Next is here. Then we can move on to functions. What is an onto functions? If any elements, that is images, the cell elements in B have the pre-image in set A, then such elements, that such function is defined as onto functions. I will show you that here. Here just look at here the elements of set A. Here D is remaining. Here in elements of set B, here what is that? Every elements of set B has pre-image in set A. Then such function is called as onto functions. So what is 1-1 function? 1-1 function means if every elements of set A has its image on the set B, then such function is called 1-1 function. And if one element has more images in set B, then such function is called as one to many functions. And what is onto function? The onto function is that is the elements of set B has its pre-image and on set A. Then such function is called as onto functions. Then if one function has both 1-1 function and onto function, then we can say that function as bijective. Function to be invertible, then if and only if, what is that? The function should be bijective. If the function is 1-1 and 1-2, then such function is called as bijective. Then we can say that such function is bijective. Then such, if a function is bijective, that means what? That function is invertible. Invertible function means there exists an inverse for the functions. A function is said to be invertible if there exists that function should be bijective. That bijective means the function should be both 1-1 function and onto function. Then such function is called as invertible and there exists an inverse for the functions. In this chapter, what we are discussing, here we are discussing inverse trigonometric functions. So what is an inverse trigonometric functions? I will give a short explanation for that. Let me show an example, that is sine 60. What is the value of sine 60 degree? Sine 60 degree is equal to root 3 by 2. So sine 60 degree means root 3 by 2. If we have to find when we get the value root 3 by 2 with the function, sine function, that we have to find. That is sine inverse root 3 by 2. So here what is that inverse of trigonometric function? Degree measurement with the sine function when we get these values. Here, what is the inverse of this sine function? Sine inverse root 3 by 2. Sine inverse root 3 by 2 is 60 degrees. So here in this chapter, we are dealing with inverse trigonometric function. So for the more details, for the more clarification, let's move on to the chapter and study what is the inverse trigonometric functions. In class +1, we have studied that the trigonometric functions are not invertible. So then if it is not invertible, how should we find the inverse of this function? That's our questions. Okay, so in this video, I will explain you how this functions, trigonometric functions becomes invertible and how to find the inverse of trigonometric functions. All are familiar with this chart. This one Cartesian products, that is Cartesian chart of our sine function. Here I'm showing the this one of a sine functions. Just look at this one. When sine 0 is, what is the value? Sine 0 is 0. Then what is the value of pi by 2? Sine pi by 2 is 1. So here it started to here and it reaches to here. Then again sine pi means what is the value? Again it reaches to 0. Then what is it's pi by 2, 3 pi by 2, it is -1. Again when it is reaches to 2 pi, it's 0. When again it reaches to again this one 4 pi by 2, it's again 1 and so on. Here just look at this one. Here when we are starting from minus pi, that is what? Here 0. Again when it reaches to pi by 2, that is minus pi by 2, it is -1. Again reaches to 0, here it's 0. Started to pi by 2, the sine function value is 1. Then when it reaches to pi, again it reaches to 0. So this is the wavelength of our sine function. Here I will show you what is the value of sine pi by 2. Sine pi by 2 is 1. Again, what is the value of sine 0? Sine 0 is equal to 0. Then, what is the value of sine pi? Sine pi also again equal to 0. If here finding the inverse of the functions, here what is that? Sine inverse of 0. Sine inverse of 0, what will be the functions? Here, sine inverse 0. What all the values we get the 0 as sine function? Here, just look at this. Here, sine inverse of 0 is equal to 0. Then again, sine inverse of pi. What is the sine inverse 0 is equal to pi. Again, sine inverse of 0 is equal to minus pi. What is this? We got 3 functions. That is 3 values for the inverse function of the value. That is inverse function of 0. We got 3 values, that is 0, pi and pi minus pi. These are the 3 values we got. For this one, I will explain you this one. Consider a domain. Here D and this one. Set A. What are the functions? 0, pi by 2, pi, 3 pi by 2, minus pi. Okay. Here, what are the values as we get? -1, 0, pi by 2, 1 by root 2, 1 by 2, root 3 by 2. These are all the functions we get. These are the trigonometric functions. Here, for the 0 function, it's also 0. Then pi, again 0. Here, minus pi, again, it also 0. Here, is it a 1-1 function? Of course, it is not a 1-1 function. Because why? Here, pi by 2, here everyone. Then what is case of 1-1 functions? Every elements they should have an exactly one image in the set B. Here in set A, what is this? It is an example of one-to-many functions. And here, it is an onto functions because here 1 by root 2 it has a value and 1 by 2 it has value root 3 by. Sine function is an onto functions, but in case of this one, that is one minus in case of this we have only many to function. It is not a one function. Only this one sine function is an onto function. So what should we have to do? In order to find out the inverse of a sine function, we have to make the sine function, that is trigonometric ratio, inverse function, so that is invertible. For in case to invertible, what are the two conditions we have to fulfill? That is one function and onto function. It is an onto function, but it's not a one function. So if it is 1 and 1 2, it will be bijective and it will be invertible. But here only we got what it is, and sine function is an onto function. So we have to make 1 function. So before that, how to find out the 1 function? We have to understand what are the domain, what are the ranges of the 6 pillars of our trigonometric ratio. Let's do. What are the 6 trigonometric ratio we have studied? They are sine, cos, tan, cosec, sec and cot. Now let's look at the first trigonometric ratio, that is sine. Then what is the domain of the sine function? The domain of sine function is, that is a real numbers, that is from -1 to 1. What is the range of this? Range is -1 to 1, that is closed interval -1 to 1. That's we have studied already in class +1. Then what is the next trigonometric ratio? The next trigonometric ratio is cos. Then what is its domain? The domain is, that is real numbers, and its range is again -1 to 1, because it is like that. I have already shown the sine function's wavelength function. This is the sine function's wavelength. So what is the highest value? That is 1 and -1. So its range is -1 and 1. Again, same example, that in case of cos, its highest range is 1 and its lowest range is -1. So what is the domain of cos? The domain of cos is real numbers and range is -1 and 1. Then what is the next trigonometric ratio? Next trigonometric ratio is tan. What is tan? Tan means the function, that is ratio of sine and cos function. Then what is the case of cos? When it becomes 0, that is when here tends to 0. Here sine 90. What is that? Sine 90 is equal to sine 90 is equal to 1. Then what will be the case of cos 90? Cos 90 is equal to 0. Such function, that is 1/0. Such function is not exist. So we can say we have to eliminate such functions. We have to eliminate the terms, the numbers or the values when we get the first function zeros, because such function is not existed. So what is the domain? Domain of real numbers, that is domain of tan is real numbers minus what are the functions is we get the cos function as 0, that is 2n plus 1 pi by 2. That is because on not only pi by 2, that is 3 pi by 2, then 4 pi by 2, 5 pi by 2, everything we get 0. So 2n plus 1 pi by 2, where n is an integers. So this is the domain of tan. Then what is its range? Its range is what? Every real numbers is. So that's enough. Next is what? Cosec. Cosec means what? Cosec means, that is inverse of sine function, that is 1 by sine. So here what we have to look, here we have to find out when the sine functions will be 0. What is which is the case that the sine function is 0, that is sine 0, sine pi minus pi. That is the case when this function, sine functions is getting 0. So 1 by sine pi, what will be the 0? 1 by 0. Such function is not exist, so we cannot include that. So what are the cases? We have to eliminate from the real numbers. We have to subtract, that is real numbers minus x, where such that x should not be equal to n pi. Then n pi, that is value of pi, that we have to eliminate, where n belongs to integers. So what is its range? Range is r minus 1 by 1, that is open interval -1 by 1. Then what is the case of sec function, sec means what? That is the inverse of cos function, 1 by cos. Then what is the cos functions? Here, when this cos function will be becoming zeros, that is 1 by cos 90. Then in this case 1 by 0. This function is not exist. So we have to subtract the such numbers or such value when we get cos is equal to 90. Which are the cos cases? That is pi by 2, 2 pi by 2, 3 pi by 2. So we have to minus that. That is real numbers minus x into such that x is equal to 2n plus 1 by 2n by pi by 2. There n belongs to z. Then what is the range? Range is r minus 1 by 1. Here we have given open interval. What is the difference between closed and open interval? Closed interval means these value. That is square bracket defines closed interval and this curved bracket that defines an open interval. Closed bracket means it strictly include these values, that is minus 1 and 1. Here in this open bracket means we are not included. It is not strictly included. That's what difference between closed and open bracket. Then what is the sixth trigonometric ratio? That is chord. Sixth trigonometric ratio is chord function. The sixth trigonometric ratio is chord. What is chord? Chord is the ratio of cos my sine. Then what we have to minus this one? Here we have to subtract the sine functions, the value of sine function when we are getting the value as 0. That is means here which value we get, which all the values we get sine as 0. Here sine 0 we get, sine pi we get, next sine minus pi we get. So such numbers. So what we have to do? 1 by 0. Such number is not existed. So what we have to do? Chord, we have to minus such numbers, that is real numbers minus x, where what is the value of the x, which value we have to minus, that which value we have to subtract, that is n pi, where n belongs to z, that is z means integer. Then what is the range? Range is all the real numbers. These are the 6 trigonometric ratios and their domain and range. First of all, we have to understand what are these trigonometric ratio, their domain, their range. Then only we can further move on to how to find the inverse of the trigonometric ratios, whether there exists a trigonometric inverse of the trigonometric ratio and everything. Sis. Thank you.